Excuse me. So since I was absent yesterday and you had a substitute, but a lot of you could not join yesterday, it was kind of a crazy day for Link or web conferencing. I'm going to go through section 4.1 very quickly today. Okay, so you may have to take notes very quickly. I also recorded it in YouTube, and you can watch it later. Okay, but I'm going to go through this very quickly. Okay, and in section 4.1, systems of linear equations in two variables. Basically, when we solve systems of linear equations in two variables, we can have three ways. We can either graph it, we can solve a linear system by what's called substitution, and we can solve linear system by elimination. So we're going to do those three main things today. But first off, they just want you to kind of conceptualize what is an ordered pair, why is it a solution of a system. An ordered pair is just a point. Okay, so we'll talk about that really quick. And then way at the end are special systems. So just write this down. If it is a true statement, then we would say infinitely many solutions. It's kind of ahead of schedule. This is going to be your last few examples that we do. I don't know if we'll get to them today because I'm going to fly through this stuff, okay? And then we have to start 4.2. If it's a false statement, like true would be like 0 equals 0. That's a true statement. What if you get 0 equals -3? That would be false. Then you would say no solution. So essentially that's it. Now remember, the book might have like an empty set. That means the same thing. Okay, so in the first, this is kind of conceptual. Where could you see this in the real life? These are two lines. Where would they intersect right there? Basically what that point right there is saying, the sales of digital cameras was the same as digital camcorders. So that was in the year 2001. And then after the year 2001, 2002 to 2008, digital cameras sales were a lot more. Okay. Let's look at this first example. Okay. Now I'm going to go through the book's directions, so you're going to have to go through this a little bit fast. But what you would do is you're basically saying, is this the point where the two lines meet? Question mark. So what you do is you substitute that point in both equations. So they show it. I'm going to go through this fast. So I usually call this equation A and this equation B. You put the point 4, -2 into equation A, and you put, -4, +2 into equation B. If it's true for both of them, then your answer is just yes. It is a solution. So it has to be true for both. Yes, it is a solution. Okay. What that really means is -4, 2 is the point where the lines cross or meet or intersect. Same thing. Okay. Now, if I were to draw this very quickly, now again, don't quote me. This is not super accurate. Okay, I'm going to kind of go backwards. Normally you would graph this first. So -4, 2, let's say it's that point there. You have your, let's do A in purple. So you have this A line here. And then you have B line maybe here. Those are the two lines, but this is where they intersect. So that's essentially what you're doing. They're just not asking you to graph. They just want you to put the point in both. If it's true for both, then you would say yes. Okay, now, here's another example. Again, I'm not going to do the whole thing for you. Here's an equation A, and here's an equation B. You're going to substitute the point into both equations. So again, here's A, here's B. As soon as you get a false, you could stop. You don't have to, if this one was first and you got a false, you could stop. Then no, the order pair is not a solution. What this means is this point is not where the lines meet or cross or intersect. Okay, so that's overall what that means. Okay, now I want you to, when we were in section 3.3, I had you guys take out a half sheet of paper. Well, on the back of this paper is this. Okay, and we're going to go over this. This is a good concept of what happens when lines cross or they don't cross and so forth. Most of your problems are going to be number 1. And I'm going to have you on top of this, and I had you print this off, but I don't know if you still have it. So if not, you're going to have to just, the pictures are probably the best. So here on down, copy that. The lines could intersect, and if they do intersect, they are going to intersect at some point. This point, we'll call it XY here because I don't know what the points are, what the coordinates are, but your solution is just that one solution, and it is your point, wherever they intersect. Okay? Now, they might ask you, and that's what this is talking about, 2 lines intersect at a single point. Okay, so that solution is your point right here, and whatever that point is there. Now, they might ask you what type of system it is. It's consistent. But down here you can just read that. It's a consistent system, and the equations are independent. So if they ask you any of that information, just refer to this chart. It's on page 212 as well. You don't have to memorize the stuff down below. Okay, now, I want to talk about slopes a little bit. When you're talking about intersecting lines, if they're going to intersect or cross, what do you know about their slopes? You're right, Jacob. What do you know about the slopes? They have different slopes. Now this is important because the last part of your homework, I think it's going to ask you to identify if the lines are going to intersect just by putting them in slope-intercept form. So if you can put them in slope-intercept form, their slopes for intersecting lines are going to be different. So you just compare those 2 slopes. Then you know if the slopes are different, they're going to have to eventually touch. Okay, now let's go to the middle picture. This is a different scenario. These are called parallel lines. If I can actually write. Parallel lines, what do you know about their slope? Okay. Same slope. And what about their y-intercept? Now remember, you're going to go y equals mx plus b, and you're going to look at your slope and you're going to look at your y-intercept. We'll look at the picture. They have the same slant, so it's the same slope, but what about their y-intercept? They cross the y-axis. That should be different. Then you can tell that the lines are parallel. You don't even have to draw it. But if you're going through the solution, we would say no solution because the lines never touch. So there's no, if you have parallel lines, the lines will never touch, so there can't possibly be a solution. If they ask you about system, it's inconsistent, and equations would be independent. Again, the bottom part I'm not asking you to memorize. Okay, last thing. These charts right here are very, very helpful when you're doing problems, kind of understanding the whole thing. Last one. And I don't know if you can see this, but this is the same line. Maybe you have a purple line on top of the black line, but they're the same line or same lines. If they're the same lines, then your solution is infinite number of solutions. Now, in your homework, they may ask you then to write your answer like this. Well, to be honest with you, you're just going to have to fill in this part of it. Yep, Emma, that's what you're supposed to. I don't know. I think there were 2 people that were able to stay. So I'm going to go through this again. And sorry if this is review, but I think it's pretty important that make sure everyone understands it, okay? Okay. You're going to basically write the equation of the line. And I think Brad came into my office today. I think we discovered that they want it in standard form. Isn't it right, Brad? Which is honestly silly to me. Why do they even go that detailed? But basically, it's one of the lines. Well, since they're the same line, it doesn't matter which one you do, but they want it in standard form. Which, again, I'm sorry, but I don't think that, why do you have to go that far? But that's the way they are, okay? Same lines. Now, if you're looking at y equals mx plus b, if they're the same line, then aren't the slopes the same? And isn't also the same y-intercept? So everything's going to look the same if you put it in slope-intercept form. Excuse me. Slope-intercept form will tell you a lot about lines. And again, we don't really get into that towards the end. But they'll say, put each in slope-intercept form and then tell, are they intersecting lines, are they parallel, or are they the same? And you can tell by just those bullets. Okay, now, the first thing, after they ask you if it's a solution, the next thing they're going to say is solve a system by graphing. All a system means is that you have 2 equations, or 2 or more, but right now it's just going to be 2 equations. Personally, I call them equations A and equation B. Okay, I just do that. It's in my own head. Here's equation A, here's equation B. So if you're going to graph it, it really depends on what you think, how you think of it. They graphed A by putting it into slope-intercept form, and then they graphed it. Then equation B, they did the same thing. Okay, and then they graphed it. So here's equation B. Now, when you go ahead and graph this for your homework, it's nice because it'll tell you where the solution is. And that point right there where they intersect is your solution. So all you're going to do is write that in for your homework. That's it. But you have to make sure it's a point. So it's parentheses, number, comma, number, parentheses. And that's it. You're done. Okay, I told you I was going through this fast. Now, the book will show you to check it. You don't have to check, okay? But the check would be like our first example. Put -3, 1 into this equation, make sure it's true. Put -3, 1 in that equation, make sure it's true. Questions so far? Okay, now we're going to go into solving systems by substitution. Your book gives directions. Okay, but the easiest way to use substitution is one variable is alone on one side, or you can easily solve it for one side. Here's all the directions. I'm not going to go through those, okay? So here's the first equation. Now, here are the steps, and I go through this again in my PowerPoint, but we just don't have time to do that. So what you want to do is, again, I call it equations A and B. You look for one of the equations that's solved for a variable. Well, this one's already solved for x. So what you want to do then is you want to substitute, and I'm just going to leave them in 1 and 2 because it'll get too confusing. You're going to substitute that equation, that into the other equation. So this x, which is 2 minus y, is going to go in for x there, into the other equation. And then you solve for y. Okay, so this is our y answer, but we want to know if these lines will intersect. As soon as you get y equals a number or x equals a number, they will intersect. So the other thing we need to do is figure out what is x equal, because we need an x coordinate and a y coordinate for a point. So now what you do is you take that answer, y was equal to 2, I believe, in that previous sign, and you substitute it into either equation 1 or 2. They chose 2. And then you say, okay, so x is equal to 0. So my y is equal to 2 and our x is equal to 0. That's our solution, 0, 2. Now they do checks, but you don't have to do checks. Okay, honestly, you can stop right there. So that's substitution. Okay. Now this should have been reviewed from a previous class, but that's okay if it isn't. Now I'm going to do example 5 with you. Okay? And I don't like A's, 1s, and 2s. I'm going to do A and B. If you ever see fractions, get rid of fractions first. So let's go ahead and get rid of this fraction. So we're going to look at 4 would be your LCD. So we're going to multiply this one by 4, this one by 4, this one by 4. So what equation B now goes to is this. These 4's will cancel. Do you all agree that it's 2x plus y is equal to 2? And equation A stays the same? Okay, so now in substitution, if they say you have to solve by substitution, they probably will. This one doesn't, but I'm going to say by substitution. So if they say by substitution, you want to look at both equations. Which one is almost already solved for a variable? Well, y is almost alone there. So I'm going to solve for y in equation B. So instead of 2x plus y is equal to 2, I'm going to subtract 2x from both sides, and I get y is equal to 2 minus 2x. Now I'm going to substitute that into the other equation. That's very important. It has to be the other equation, which is going to be our A. So equation A looks like negative 2x plus 5y is equal to 22. So instead of y, we're going to put this, 2 minus 2x. Just going to copy everything else down. So if they have 2x plus 5 times that y, which is 2 minus 2x, equals 22. Now I'm going to solve for x. So we have 2x plus 10 minus 10x is equal to 22. Negative 12x plus 10 is equal to 22. Negative 12x is equal to 12. And I know I'm going over this a little fast. X is equal to negative 1. Once you have x or y equal to a number, you're going to substitute that into, now it doesn't matter, either equation A or equation B. I think B looks easier. There's not as many negatives, and y is almost by itself. So instead of x, I'm going to substitute in negative 1. So I have 2 times negative 1 plus y is equal to 2. Or negative 2 plus y is equal to 2, or y is equal to 4. But remember, our solution has to be in the form of x comma y. So we would write negative 1 comma 4. Go ahead and change your color to maroon with white stripe if you are following. If this is all making sense to you, maroon with a white stripe. I know some of this is fast, but it should be review. Okay. And I am here afterwards too if we want to go over questions. Okay, now we're going to go into the next objective. The next objective is solving by elimination. Some books call it the addition-subtraction method, but elimination is very common as well. Okay, now these again are in the book. I'm not going to write down all these directions. I'll just go through it with you as we're going. your goal is to get one variable to be opposites. Can you see that in this problem? Is there one variable that are opposites? Which variables are those? Good. The x's. One's negative 2x and one's positive 2x. So then what you do, and a lot of people like elimination, is you add straight down. Once you get them to be opposites, then add. And you want to line them up, okay? And the reason why you want to line them up, look what happens. Those will go away. 3y plus 2y is 5y, and negative 10 plus 5 is negative 5. Then you're going to solve for the variable. So I'm going to divide both sides by 5. So y is equal to negative 1. The rest is like substitution. Now you're going to substitute this into either equation A or B. I'm going to go with B just because it looks easier. So 2x plus 2 times negative 1, that was our y, is equal to 5. 2x minus 2 is equal to 5. 2x is equal to 7. X is equal to 7 halves. And yes, it's okay to get a fraction. So our solution is 7 halves, comma, negative 1. Change your color to green if you think you like elimination better. Maybe some of you just don't know right now because it's all so fast. A lot of people like elimination better if you can get the numbers to be opposites, right? Scott isn't sure. That's okay because, you know, maybe you haven't seen this in a while. Okay, let's look at example 7. I think that's the next one. Now, if you notice example 7, there are no opposites, right? The x's are not opposites. And the y's are not opposites, but that's really the goal. Get opposites. So you have to decide, do you want your x's to be opposites or do you want your y to be opposites? Okay, some say y because one's already positive, one's already negative. Now I'm going to go out on a limb and I'm actually going to do the x's because I want you to see if you both have positives. If you both have positives, what do you do? So I'm going to multiply the top one by a number and the bottom one by a number. But you have to look at between 2 and 3. What's the LCM, least common multiple, between 2 and 3? It's like the LCD. What's the first number both 2 and 3 will go into? 6. Okay. So I'm going to multiply the top one by negative 3. And the bottom one by positive 2. Why the top one by a negative number? And the bottom one by a positive number. I want my numbers to be what? Opposites. Okay, and I usually pick the top one to be negative, and I'll show you why later. Okay, so if you distribute negative 3 to each, your new A is going to be negative 6x minus 9y is equal to, what is that, negative 57. And my new equation B, if I distribute the 2, make sure your 2 goes in everything, 6x minus 14y is equal to negative 12. Once I have the opposites, then I add. And the reason why I like the negative on the top, because when I'm adding, to me it's not confusing. I'm not confusing it with subtracting. So when I add, look at those will go away. And I have negative 23y is equal to negative 69. So what is y equal to? Positive 3. And again, you substitute this into either equation. So the second time you do something, it could be either one. It doesn't matter. I'm going to go with A, my original A.
Ms. Parker?
Go for it. Yes.
Why can't you just add the x's, like 5x?
Because you won't eliminate the variable, AC.
Okay. Oh, yeah. Okay.
X's and Y's.
Yep. Okay.
No, that's a good question because that makes sense, asking that question because you just, you don't see it. But when you add them as is, you won't eliminate a variable, so you have X's and Y's, and then what, you can't solve. Good question. So 2x is equal to 10, x is equal to 5. So your solution is 5, 3. Make sure your x is first and your y is second. All right. Now, this is 4.1 still. This is 4.1. Okay, now, remember what I said earlier. We're going to get into some special cases. Okay, and I'm going to go through this very quick. But if you get a true statement, that means you have infinitely many solutions. If you get a false statement, that means there's no solution. That's kind of the guideline. Okay, so let me show you an example. Now, they won't tell you which way you should solve the system. So it's your choice on this problem. But no, I am collecting your next test. So there will be a problem that says solve by substitution, and you have to do it that way. There will be another problem that says solve by elimination, and you have to do it that way. There'll be another one that says solve by graphing, and you have to graph it. Then there'll be one that just says solve. Then it's your choice. So something like this is your choice how to solve. How would you solve this one? Choice, I only want you to do substitution or elimination. What would you go with? Yeah, and I see both different answers. So it's really what you prefer. Now, why did you say substitution, Tish? Or Emma?
Because you have an equation that's almost done for you.
Is that what you're basically saying? Y is almost by itself?
Yeah.
Okay. Now, they ended up doing elimination. Does not matter. It does not matter. Okay. But that's probably what I would have done too because of the y is almost by itself, but it's up to you. What they chose to do instead was they would do, I think they multiplied the top one by 4. So you get 8x plus 4y equals 24. Okay. So you don't even know that this is a special case. I can show you substitution, yes. But you don't even know that this is a special case right away. But however you solve it, if you notice, those get eliminated, so they really go to 0. And the stuff on the right side also goes away. So because it's a true statement, 0 equals 0 is a true statement, then you would say the solution set is really infinitely many solutions. Now, honestly, I'm okay with that, but the book wants you to go further. The book wants you to write your answer like this, because what infinitely many solutions means is that it's the same line. They're really saying that these are the same line. Right? Same with this. Those are really the same line.
Ms. Parker?
Yep.
But don't you have to multiply 4 by both of the, like the -8 and the 2x?
We're only doing it to the top equation.
I thought you had to do it to both equations.
Nope. Only to get the opposite. So if you look, Lacey, in the previous problem, we had to multiply to both in order to get them to one to be 6 and the other one to be -6.
Yeah, so you could just multiply the one solution then?
As long as you get the opposite. So see how this is -8 down here already?
Yeah.
We only had to get 8 up here so that they're opposites.
Okay.
So sometimes you only have to multiply one equation. Good question. Okay? But I just wanted to show you in infinitely many solutions, it's really the same line. So they're going to want one of the equations, since they're the same line, you're just going to have to write the equation there. But they want it in standard form. Wonderful, right? Yeah, we're going to do 3 variables today. Whew. Okay. Now here's another one, and I told you I would, I don't want to do that one by substitution. I'll show you this one by substitution. Okay. If I did this for substitution, I get y equals 6 minus 2x, right? In equation 1. Put that in here. So this one's by substitution. Get the same answer, but I want you to see the difference. Okay, so here's your y, there's my y. Okay, then we have distribute, negative 24 plus 8x is equal to negative 24. These will cancel out, so you're left with negative 24 equals negative 24. Is that a true statement? Yes. So we still get the same answer. Does that make sense? Okay. Now let's look at example 9. Same thing. You're going to try and solve it. I bet you they're going to do elimination because they're going to get this guy to be opposite. So they're going to multiply the top of my negative 2, so they're opposites. So you've got negative 8x, positive 6y, and negative 16. Then you add straight down. These will get eliminated. These will get eliminated, but these don't. So you get 0 equals negative 2. False statement, which means there are no solutions. What does it mean about the lines? Lines are what? Parallel. Good. So I wanted you guys to see that when you're solving, sometimes you can get no solution.